I need you to forget everything you think you know about distance, right now, because what I'm about to explain will fundamentally change how you see the universe. Light years aren't just big numbers. They're not just measurements that astronomers throw around to sound smart. They're distances so incomprehensibly vast that our brains literally cannot process them. And once you truly understand what a light year means, you'll never look at the night sky the same way again. Let's start with something simple. Light. The fastest thing in the universe. Nothing can move faster than light. It travels at 299,792,458 meters per second. That's about 186,282 miles per second. In 1 second, light can circle the entire Earth 7.5 times. Think about that for a moment. In the time it takes you to blink, light has already gone around our entire planet multiple times. That's insane speed. Speed that makes our fastest rockets look like they're standing still. Now here's where it gets interesting. A light year is the distance light travels in 1 year, not the time. The distance. So we're taking the fastest thing in the universe and letting it run at full speed for an entire year. 365 days. 8,760 hours. 525,600 minutes. And the distance it covers is 1 light year. When you calculate it out, 1 light year equals about 9.46 trillion kilometers. That's 5.88 trillion miles. Trillion with a T. But numbers that big don't mean anything to our brains. Our minds didn't evolve to comprehend trillion. We evolved to understand distances we could walk, distances we could see, distances that mattered for survival. So let me put this in perspective. If you could somehow travel at the speed of light, which is impossible, but let's pretend, you could reach the moon in 1.3 seconds. You could reach Mars in about 3 minutes when it's closest to Earth. You could reach the Sun in 8 minutes and 20 seconds. That's already hard to wrap your head around. Now imagine traveling at that impossible speed for an entire year, non-stop. No breaks. Just pure light-speed travel for 365 consecutive days. The distance you'd cover is 1 light year. And space is measured in these units. Not in hundreds of light years, not in thousands, in millions, billions. The observable universe is about 93 billion light years across. Let that sink in for a moment. The nearest star to our Sun is Proxima Centauri. It's 4.24 light years away. That means the light we see from Proxima Centauri tonight left that star 4.24 years ago. When you look at Proxima Centauri, you're literally looking into the past. You're seeing it as it was over 4 years ago. If that star exploded right now, we wouldn't know for another 4 years. The explosion would happen, the star would die, and we'd still see it shining in our sky for 4 more years because the light from the explosion hasn't reached us yet. Think about what that means for everything else in the night sky. The North Star, Polaris, is about 433 light years away. The light you see from Polaris left that star in the year 1591, when Shakespeare was alive. When the Renaissance was happening, that light has been traveling through empty space for over 4 centuries just to reach your eyes tonight. You're not seeing Polaris as it is now. You're seeing Polaris as it was when humans were just beginning to explore the Americas. But that's nothing. The Andromeda Galaxy, our nearest major galactic neighbor, is 2.5 million light-years away. The light from Andromeda that reaches your eyes tonight left that galaxy 2.5 million years ago, before modern humans existed, before Homo sapiens walked the Earth. Our ancient ancestors were just beginning to use stone tools when that light began its journey, and it's been traveling through the void ever since, finally arriving at your retina tonight. This is where our brains start to break, because when you look at Andromeda, you're looking at a galaxy as it existed 2.5 million years ago. You have no idea what Andromeda looks like right now. It could have been destroyed by some cosmic catastrophe. It could have collided with another galaxy. Entire civilizations could have risen and fallen in Andromeda during the time it took for that light to reach us. And we wouldn't know. We can't know. Because the information, the light, hasn't gotten here yet. The universe isn't just big in space, it's big in time. Every direction you look in the night sky, you're looking into the past. The farther you look, the further back in time you see. Telescopes aren't just magnifying glasses, they're time machines. When the James Webb Space Telescope looks at distant galaxies 13 billion light-years away, it's seeing those galaxies as they were 13 billion years ago, shortly after the Big Bang. Those galaxies might not even exist anymore. They might have evolved into something completely different, but we're seeing their ancient light only now. This creates a strange problem. We can never see the universe as it is. We can only see it as it was. And the farther away something is, the older the image we see. It's like trying to have a conversation with someone, but every word takes years to reach you. By the time you hear what they said, they've moved on to completely different topics. The universe is having a conversation with us, but we're only hearing the beginning of sentences that started billions of years ago. Let's make this even more mind-bending. The speed of light is finite, but the universe is expanding. Not just expanding slowly, accelerating. Galaxies at the edge of the observable universe are moving away from us faster than the speed of light. Not because they're traveling through space faster than light, which is impossible, but because space itself is expanding between us and them. This means there are galaxies we can see right now whose light will never reach us again. We're watching them fade away forever. There's a cosmic horizon, a boundary beyond which we can never see, no matter how good our telescopes become. Light from beyond that horizon will never reach Earth, because the space between us is expanding too fast. Those regions of the universe are forever beyond our reach, forever unknowable. Entire galaxies, potentially trillions of them that we will never see, never study, never know existed. And here's the truly disturbing part. Because of this expansion, there are galaxies that existed, that formed stars and planets, that potentially harbored life, whose light will never reach us at all. They came into existence, lived their entire existence, and died, all in a region of space so far away that the light they emitted never had time to reach us before the expansion carried them beyond the cosmic horizon. They existed, but from our perspective, they never existed at all. Now let's talk about what this means for space travel. We get excited about going to Mars. Mars is, at its closest, about 54.6 million kilometers away. That's 3 light minutes away. Light from Mars takes 3 minutes to reach Earth. But actually getting there with our current technology takes about 7 months. We're traveling at a tiny fraction of light speed. The fastest spacecraft we've ever built, the Parker Solar Probe, reaches speeds of about 700,000 kilometers per hour. That sounds fast, until you realize light travels at over 1 billion kilometers per hour. If we wanted to reach Proxima Centauri, our nearest stellar neighbor with current technology, it would take about 6,300 years. That's longer than recorded human history. You'd need multiple generations living and dying on the spacecraft just to reach the nearest star. And Proxima Centauri is basically in our backyard on cosmic scales. Most stars are hundreds or thousands of light years away. The center of our Milky Way galaxy is about 26,000 light years away. Even if we could somehow travel at the speed of light, which we can't, it would take 26,000 years to get there. The Milky Way itself is about 100,000 light years across. To cross our own galaxy at light speed would take 100,000 years. And our galaxy is just one of potentially 2 trillion galaxies in the observable universe. This is why scientists get frustrated when people ask about visiting other galaxies. Andromeda, our nearest major galaxy, is 2.5 million light-years away. Even at light speed, it would take 2.5 million years to get there. With our current technology, it would take trillions of years. The universe would die of heat death before we arrived. It's not just difficult. It's essentially impossible with anything resembling current physics. But here's where it gets even stranger. Einstein's theory of relativity tells us that time is relative. It moves differently depending on how fast you're going. If you could somehow travel at speeds approaching the speed of light, time would slow down for you relative to the rest of the universe. This is called time dilation. It's been proven. It's real. Astronauts on the International Space Station age slightly slower than people on Earth because they're moving faster. So, theoretically, if you had a spacecraft that could accelerate to near light speed, you could take advantage of time dilation. From your perspective on the ship, a journey to a star 10 light-years away might only take a few years. But when you arrived and looked back at Earth, hundreds or thousands of years would have passed. Everyone you knew would be dead. Civilizations would have risen and fallen. You could travel to the stars, but you could never come home. Not to the home you left. That home would be ancient history. This is the tyranny of the light year. It doesn't just measure distance. It measures isolation. It measures the fundamental loneliness of existence in a universe this vast. Every star system is an island, separated from every other island by oceans of space so wide that crossing them is effectively impossible. We can see our neighboring islands. We can study them, but we can probably never visit them. And this brings us to one of the most profound implications of light years. If intelligent life exists elsewhere in the universe, and statistically it almost certainly does, we may never communicate with it. Not because we lack the technology to send signals, but because the distances are too great. If the nearest alien civilization is 1,000 light-years away, and we sent them a message today, it would arrive in the year 3025. If they responded immediately, we'd get their reply in the year 5025. A round-trip conversation would take 2,000 years. You can't have a conversation across those timescales. You can't build a relationship. You can't even share information effectively because by the time the information arrives, everything has changed. Imagine sending a message about human technology in the year 1025 and expecting it to be relevant today. We didn't even have gunpowder in 1025. The entire modern world would be incomprehensible to someone from that era. This is why the Fermi paradox is so troubling. The Fermi paradox asks, if the universe is so vast and so old, where is everybody? Where are all the alien civilizations? With billions of stars in our galaxy alone, many with planets, some of those planets should have developed intelligent life. Some of that intelligent life should be millions of years more advanced than us. They should be everywhere. So where are they? One possible answer is the light year. The distances are simply too great. Even a civilization millions of years more advanced than us might find interstellar travel impractical or impossible. They might exist, but they're isolated on their home worlds, separated from us and each other by distances that make contact effectively impossible. The universe might be teeming with intelligent life, but we're all alone together, unable to bridge the gaps between us. Another disturbing possibility is that we're late. Remember, when we look at distant parts of the universe, we're seeing the past. The galaxies we see 10 billion light-years away appear as they were 10 billion years ago. They've had 10 billion years to evolve since then. Entire civilizations could have emerged, flourished, and gone extinct in that time. We might be looking at graveyards, dead civilizations whose ruins we're seeing from across the cosmos, not knowing they've been gone for eons. Or maybe we're early. Maybe intelligent life is rare and we're among the first. The universe is only 13.8 billion years old. That sounds ancient, but stars will continue forming for trillions of years. The universe is still young. Most of the stars that will ever exist haven't been born yet. Most of the planets that will ever exist haven't formed. Most of the life that will ever evolve hasn't begun evolving. We might be among the earliest intelligent species in a universe that's just getting started. But back to light years and what they mean for our understanding of reality. Here's something that will twist your brain. The universe is 13.8 billion years old. The most distant objects we can see are about 46.5 billion light-years away. Wait, how is that possible? If the universe is only 13.8 billion years old, shouldn't the farthest we can see be 13.8 billion light-years? How can we see objects 46.5 billion light-years away? The answer is expansion. Those distant objects emitted their light 13.8 billion years ago, shortly after the Big Bang. But in the time it took that light to reach us, the universe expanded. The objects moved farther away. So the light traveled for 13.8 billion years. But the objects are now 46.5 billion light-years away, because space itself stretched while the light was in transit. The universe is bigger than its age in light-years would suggest, because it's been growing the entire time. This means there are objects in the universe that are now so far away that we will never see them, even though they exist within the observable universe. Their light hasn't had time to reach us yet, and because of accelerating expansion, it never will. The observable universe is shrinking in terms of what we can access, even as the actual universe continues expanding. Think about that. There are galaxies out there right now, filled with billions of stars, potentially hosting trillions of planets, and we will never see them. They exist, but they're forever beyond our cosmic horizon. They might as well be in a different universe entirely. And every day, more galaxies cross that horizon, disappearing from view forever. This is what light years represent. Not just distance, but the fundamental structure of reality itself. The universe isn't just big. It's structured in a way that makes most of it inaccessible. We live in a tiny bubble of space and time, able to observe only a fraction of what exists, and that fraction is shrinking. We're in a universe that's isolating us more every second. And yet, despite all of this, despite the incomprehensible distances, despite the isolation, despite the impossibility of ever exploring most of what exists, we can still observe, we can still study, we can still learn. Those photons that have been traveling for billions of years finally reach our telescopes and tell us stories about the universe, about how it began, about how it evolved, about what it contains. Every light year is a piece of history. Every distant galaxy is a window into the past. The universe is sending us messages from across time and space, and we're learning to read them. We might never travel those distances, but we can study them. We might never meet alien civilizations, but we can search for their signals. We might be isolated, but we're not ignorant. So, when you look up at the night sky tonight, remember what you're actually seeing. You're not seeing stars as they are now. You're seeing them as they were years, decades, centuries, millennia ago. You're looking at light that has been traveling through the void since before you were born, since before your grandparents were born, since before humans even existed. And that light finally arrives at your eye tonight, completing a journey that spanned the cosmos. Light years break our brains because they force us to confront the true scale of existence. We are tiny. Our planet is a speck. Our solar system is insignificant. Our galaxy is one among trillions, and the distances between everything are so vast that they might as well be infinite. We are isolated in space and time, living on a tiny world, watching ancient light from distant stars, wondering if anyone else is out there doing the same thing. But maybe that's beautiful. Maybe the vastness is what makes existence precious. Maybe the isolation is what makes connection meaningful. Maybe the incomprehensible scale of the universe is what gives significance to the small corner we inhabit. We might never cross the light years that separate us from the rest of the cosmos, but we can still look, we can still wonder, we can still dream, and maybe that's enough.